So you need to figure out whether that's too high. Which is too high.
So
that
this
deck
piece right now is my template, and it is probably what looks to be about maybe 1/8 of an inch too high, too tall.
And how do you know that?
Because I'm touching, I can feel it in there, and here I can catch a fingernail, so it's definitely too high. And it looks like not only do I have to bring it down enough to make this sit flat, but I also have to bring it down enough to get some layers of fiberglass on there. So
how will you know how thick for the fiberglass to be?
The layers of fiberglass are a known quantity. I mean, they are a certain thickness. If I put 4 layers on there, and it's and they're like usually they're like an 1/8 inch thick each. They're like fabric.
Okay.
So that would be, if I put 4 layers down, that would be 4/8 or 1/4 of an inch.
Now you came into another issue. You were showing me a piece of styrofoam. Can you explain what that is?
So this, I'm going to take up the floor now because I don't need it to measure anymore. I can see what I've got.
Okay.
I'll show you where that piece goes.
You mean the deck?
Yeah, the deck. No, I'm going to take up the deck and get the floor.
Okay. I'm confused because you keep calling that that wooden thing that you made a floor.
It's an easy thing to confuse, and I think probably people who do ship inspections would probably confuse that. Alright, so the piece I was showing you is up there. I'll bring it and give it a close-up. So this piece is a cross-section of what I thought was wood, and is actually, not only is it foam, but it's not even, it's like a low-density foam. It's like not even styrofoam.
Yeah, it sounds like styrofoam.
And it goes in here, so it provides 0 structural support. They do all the structure by encasing it in this fiberglass. So this laminate that they put on there is the only thing.
Show where it fits. How did it fit in there?
It goes right in here.
Wow. And it's styrofoam.
And it's made out of styrofoam.
And it connected to where on the deck?
And this connected, when it was all down, these tabs were side by side, glued on. This one stayed on the boat when I lifted the deck, and this one came with the deck because it was just completely, it was broken. I mean, there's no other way to put it.
So that's just one of the problems. While we have the video on, can you kind of explain where some of the other problems were? Because I see you have other floor pieces back there, and you've taken out at least the one that you replaced with that particle board.
The first one I took out was up here. It was the worst, and it was just like these. It was painted white on both sides and made out of plywood that's open on the ends, which you can, there's no fiberglass covering them. If they get wet inside. This one was
so they were not sealed either.
No, they weren't sealed, and they're not sealed here and here, and they're also not sealed on the bottom. I can feel plywood right here, and it's just.
Can you lift up that?
I can't take this one.
No,
out.
the other one in front. Yeah.
This one?
Can you take that out for a second?
Yeah.
And so it can be seen how little support that actually is.
Right. These
and
are.
There were 3 of those.
There were 3. I took one out already.
Okay.
So these 2 will come out as well, but I don't want to take them out until I have one in, because these are actually still supporting the keel. And what you don't want to do is completely remove all the support and have the keel, the boat start moving. We want, when we're done, we want the boat to be exactly where it was when I started.
So this is the bilge, just for reference.
Yes.
This is our bilge.
This is the top of the encapsulated keel. It doesn't have adjustments for the bolts or anything that you can get to.
And the keel is the problem that we're having right now.
The keel is the problem, and actually when the boat was on the sling, they were when they were pulling us out last fall, of course on the sling everything kind of sways back and forth until it stabilizes. Unfortunately, they noticed that when the rest of the hull sat still, the keel was still appeared to be moving. So then when they went over and started pushing on it by hand, they could actually deflect it about 4 to 8 inches. So that you're not supposed to be able to do that. 4 to 8 is pretty
darn lot, yeah.
And what we found is that because these are so short, for one thing, they don't go out into here where they can actually keep the the hull, you know, supporting the keel. And they also allow it to basically flex from here in what they call an oil can. It's like an oil can. It's the same, really the same process that you have when you have an old oil can that you pump with your thumb to make it get oil out of it. So, and they call it oil canning. And the reason we were getting it is because these just don't extend far enough. This is as built, so probably at some point it just broke free. So not only were these too short to be of any real use to, you know, use the hull to stabilize the keel, but these were broken. So this is, and you can, this is actually not been ever connected. It's like it was like it was never really well connected in the first place. And there were 3 of them, and they came off with the deck. There's still there's supposed to be 3 tabs on each side, and they would be the thing that reaches out and gives you kind of a spring effect that helps keep the keel stable. They were all ruined. I mean, these are.
So you have to figure out a plan to replace those with something that will still keep that spring, but be stable enough to not break.
And what we're going to be doing is transmitting the force that wants to move the the keel side to side. And we're going to keep the keel is right here. This is actually, you can feel it if it's there's actually, the seam is right here. So the idea is to transmit that force out further so it would not be able to flex the hull anymore, and it will also support the keel with more you know, the kind of the tension and compression from side to side. Whenever you heel over from one side to the other, you want the keel to stay straight, and that's what we're going to be doing, is making it so it will stay.
So this boat has a particularly large, long, heavy keel, doesn't it?
Yeah, this is a full keel boat, and it has it doesn't have a shoal keel, so it's quite a long moment of movement from the bottom of the keel all the way up to here. Which
gives it stability.
It does. It makes it it makes it so it's not so prone to capsizing, but it is also you know, problematic if you have
a lot of stress on them.
A lot of stress, yeah. You got to have a hull that can take it. And encapsulated keels, you can't just remove the keel and tighten it up or anything.
So it's a unique problem, but it actually is a problem because the boat is so stable and has that large keel.